This is Mr. Ashton going through the Mathematics Unit 1 Non-Calculator Intermediate paper from November or the autumn of 2017. Okay, so as always, the first page is just the formula sheet, so we probably won't need that. So we'll start cracking on and looking at the first question. Okay, so the first question says, what is 3 to the power of 4 times by 10 cubed? Well, what they're looking for you to realise is that 3 to the power of 4 means 3 times 3 times 3 times 3. So there are 4 3's with time signs in between. I'm then timesing that by 10 cubed, which would be times 10 times 10 times 10. If we start answering that in certain orders, it'll make our lives a lot easier. So 3 times 3 is 9. Times that by 3 times 3, which is also 9. And then times by 10 times by 10 times by 10 is the same as times by 1,000. 9 times 9 is 81. 81 times by 1,000 is 81,000. The next one is commonly answered wrong. People get this wrong all the time. It says, how many 0.5s fit into 1? That's what that's saying. Counting 0.5s till you get to 1. 0.5, 1. The answer is 2. If you wanted to use similar fractions, we don't like a decimal being in a fraction, so what we could do is times it by 10 to make it have a new denominator of 5. Whatever I do to the bottom, I must do to the top, and that would be 1 times 10 to be 10. 10 divided by 5 is also 2. It's because it's a similar fraction, it will work. The next one you have to write in column form, so we have our units and a tenth in the first decimal. I then want to subtract a unit, decimal point, a tenth, and a hundredth. I now want to take those away. Mathematically, if nothing is there, the number that represents that would be 0. I can't do nothing take away 2, it would be minus 2, so I steal 1 from this guy. So it becomes 10 take away 2, which is 8. 5 take away 8 again, I can't do it, it becomes a negative. So I steal 1 from this guy. 15 take away 8 is 7. Decimal point lined up. 4 take away 3 is 1. And then for D, you have to have the denominators the same on both. So we're going to say it's 5 out of 6, take away. I can turn the smaller denominator into 6 by timesing it by 2. But whatever I do to the bottom, I must do to the top. So 2 times 2 would be 4. So 5 out of 6 take away 4 out of 6 would leave me with 1 out of 6. And then 0.2 times 0.3, again, really commonly answered wrong here. People say it's 0.6. It's not. It's going to be based on 6. If we write down here 2 times by 3, that is 6. If I divided that by 10 to get 0.2 times 3, that is what would be 0.6. And that's because I've divided this side by 10, so it means I have to divide this side by 10. But now what I'm going to do, I'm going to keep that 0.2 the same. I'm actually going to make this 10 times smaller, so I've divided this by 10, which means I have to divide my answer by 10 again, which will give me 0.06. Okay, so really commonly answered incorrectly there. The answer is 0.06. That's the one that you needed. Okay then, over the page, have a quick read of them, and I'll start to go through the answers. Okay then, so the first one says g times g times g can be written as 3g. No, we've already seen on the other page that's false. If it's g's with time signs in between, it would be g cubed, okay? 7y take away y would be 7. No, that's not true. That's y plus y 7 times. You take one of them off, that would be 6y. So that's also false. A over 4 divided by a would equal a quarter. Now, if I write that calculation out, I can write divided by something as times by 1 over that thing. Okay, so I'm going to change it to divided by a is the same as timesing by 1 over a. So for instance, if I was saying divided by 2, timesing by a half gives me the same answer. The a's would cancel then, giving me 1 quarter, so that is indeed true. The next one says a over 2 plus a over 2. Well, that's a half a plus a half a. A half a plus a half a will give me a whole a, which that's absolutely true there. And then for the last one here, it says if a equals 1, b equals 2, c equals 3, a plus b plus c is equal to abc. So 1 plus 2 plus 3 will give me 6. And then if they're touching, these guys are timesing. So 1, we need a bracket here, 1 times 2 times 3. 1 times 2 is 2, 2 times 3 is 6. They're both 6, they're equal. So that's absolutely true when I use these numbers. Okay then, over the page. It says In this part of the question, you'll be assessed on the quality of your organisation, communication, accuracy in your writing. You do not need to write an essay for this, just plenty of using the signs. So centimetres for length, centimetres squared for area, centimetres cubed for volume, and just a brief explanation of what you're doing, okay? You don't have to write a huge amount of things here, okay? It says 2 cuboids shown below have equal volumes. Well, that's really important. So the volume of this guy is equal to the volume of that guy. So I'm going to say cuboid A. That would give me a volume of 6 times 2 times 3, which would be 6 times 2 is 12, 12 times 3 is 36 centimetres cubed. This will be how we pick up one of the 2 marks by just making sure that we give the units of things that we're working with. So volume is always measured in centimetres cubed. So from here I can say because they have the same volume, or because they have equal volumes, we can say that 2 times by the height must be equal to volume B. And volume B, we know, is 36. So we can say 4 times H is equal to 36. Now, I don't need to put centimetres cubed for this bit because I haven't finished my answer yet. And then to get H by itself, we divide by 4. So dividing both sides by 4 gives me an answer that H is 9 centimetres. That's where I put my final answer, centimetres there. So it says calculate H of cuboid B. You must show you're working. Well, I've just done that, okay? So putting centimetres cubed there, centimetres there, and I've given a brief explanation why I was able to write that, okay? For the next part, part B, it says, let me just get the camera nice and clear for you. It says, how many centimetres cubed are there in 2 litres? You need to know the following conversion. 1 litre is equal to 1,000 centimetres cubed. I'm asked to go and find out what 2.5 litres is. Well, what have I done to 1 to get 2.5? I've times it by 2.5. Whatever I do to one side, do to the other. And that should be a reasonably easy calculation for you to do as we're doing 2.5 times by 1,000. Okay then, over the page, it says a fraction is written as A over B. The fraction is a multiple of 2. Now, for it to be a multiple of 2, 0.2 multiples are the 0.2 times table. So 0.2, 0.4, 0.6, 0.8. I am going to write 1.0, but I can cross it off straight away. Because it is a fraction, and it's written as A over B, we know it's not going to be anything bigger than 1. We're then told that the fraction is greater than a half. So if I look at the numbers that are greater than a half, it can only be 0.6 or 0.8. So I can disregard these 2 here, okay? So greater than a half, 0.5, can't be 0.2, can't be 0.4, okay? We're then told, underneath, we're told that the fraction is less than 75%. So 75% as a decimal would be 0.75, because percent means per 100. It means divided by 100. 75 divided by 100 is 0.75. Well, that counts out 0.8 then. It can't be that either. So, lo and behold, we're left with 0.6, which must be my only one that fits. And it wants that as a fraction in the form A over B, where they're whole numbers. Now, you should know 0.2 is 1/5. So 0.4 is 2/5. 0.6 would be 3/5, 4/5, and the last one being 5/5, 1 whole. But we already know it's none of those, so that's my answer. It's 3 over 5. Question 7. It says, write down the next 2 numbers in the sequence. So what you need to do is you need to go and check what's happened between term to term. Okay? What have I done to 22 to get 21? Take away 1. 21 to get 18, take away 3. 18 to get to 13, take away 5, and then we don't know. So look at this pattern here. I assume that I then take away 7, then take away 9. That's what the pattern looks like to me. 13 take away 7 is 6. 6 take away 9 is -3. Expanding means I have to multiply the number on the outside by both of the numbers on the inside. So 5 times by 3x will give me 15x. The sign in the middle is minus. 5 times by 2 is 10. Okay? To go and work out the next one here, the equation, I look for the smallest x, as I have 2 x's, one on each side. we get rid of the smallest x, so I take away 4x from each side. 9x take away 4x gives me 5x. I still have that plus 3, he's still on that side there. 4x take away 4x is cancelled, and then I still have a plus 5, which we can just write as 5 now. To now try and solve and find x by itself, we get rid of anything not physically attached to the x. So the 5 is, so we get rid of the plus 3 first, because it's easier to get rid of this. We take away 3 from both sides because it's the inverse operation. That effectively cancels out those two sides there, and then 5 take away 3 is 2. Now, final one I have to do, and this is probably the hardest bit, says 5x, which means 5 times x equals 2. To get rid of that times by 5, we divide by 5 on both sides, effectively cancel them out, leaving me with x. And this is where people get confused. Go, oh, 2/5. Well, we know from the last question what 2/5 is. It's 0.4, but it's absolutely fine to leave your answer as 2 over 5, or if you want to, you could write x equals 0.4. Either of those will get the marks. That's fine. That is also fine. Okay, then question number 8. It says Sarah is in charge of a game at her school's Christmas party. The two spinners are spun, or the two fair spinners are spun as shown in the examples below. People can make a 2-digit number by using the numbers shown on the spinners using the following rule. Multiply the first number by 10 and then add on the number on the second spinner. So for instance, if we were to use the numbers spun here, the first spinner has landed on 2. We'd do 2 times 10, which is 20, and then we'd add this number on here. 1, 20 add 1 is 21. That's how they got that number there. How many different numbers can be made playing this game? The way that you do this is you count the total number of outcomes on the first one, so 3 outcomes on the first one, and you multiply it by the total number of outcomes on the second one. So that would be also 3, 1, 2, 3. 3 times 3 is 9, so 9 outcomes in total. So 9 outcomes in total. It says write down all the prime numbers that can be made in this game. So I'm going to have to think about every combination that can be made. So let's start pretending that the spinner landed on 1. I'd times it by 10, and then I'd add on 1 from the other spinner. So that would be 11. But I could have got 1 and 2, which would be 12. I could have got 1 and 3, which would have been 13. Now, these two numbers are both prime. This number is not, so I'm going to disregard that answer. I could have spun 2 on the first one. So 2 times 10 is 20. Add the 1. 2 times 10 is also 20. Add the 2. And 20, add 3. 20 add 1 is 21. That is not prime because 7 and 3 both go into it. 22 is also not prime because 2 and 11 go into it. 23, however, is. And then finally, I could have spun 3, so that would be 30. 30 plus 1 is 31. That is prime. 30 plus 2 is 32. That is not prime. And then 30 plus 3 is 33, and that is also not prime because 3 and 11 go into it. Okay, so I had 1, 2, 3, 4 answers that gave me prime numbers. I'm then asked, what is the probability that someone gets a prime number? To work that out, I'd say it would be the number of primes, 4, out of what was there in total, 9, 4 9ths. Part D is on the other page. Have a quick read of it and I'll start to go through it in a moment. Okay, it says, Sarah charges £1 to play the game once. Each player who makes a prime number from their spins wins £2. How much profit would the school expect to make when 180 people play the game? So the first thing I'm going to do is work out my takings. So my takings is going to be 180 people, all paying £1. So times that by £1 each to get £180. That's how much we take. Our expected winners. Well, we know the probability is 4 9ths, and I'm told that 180 people play the game once. So what I need to do is work out what do I do to 9 to get it to 180. Now, there will always be a link between your denominator and the number they give there. And what I would recommend doing is either halving, that would give me 4.5, so that would be no use. So let's try doubling instead. So if I double 9, I get 18. If I double the bottom there, I have to double the top to get 8. And then I can see a really nice obvious link that if I times that by 10, I would times the top by 10. And that tells me that if I play the game 180 times, I'd expect 80 winners. So 80 winners expected. So from there, we'd have 80 winners, all getting £2 each. So we times that by £2. That would give me 160 quid that I'd have to give away. So my profit would be the takings, 180, take away the amount of money I give away as prizes, so my profit would be £20. Question 7. It says ABCD is a quadrilateral. It then tells me the angles there. They've written all of these in here. It then says PQ and P and Q lie on the quadrilateral such that AP, so A to P, is equal to A to Q. So basically they're telling me that this line here is the same as this line here. And what we tend to see, if that's the case, is we tend to see a dash given as such there. Okay? Now, in order to go and do the next bit, it says prove that APQ, so from A to P to Q, prove that this is an equilateral triangle. Now, for it to be an equilateral triangle, all the angles must be 60 degrees. Now, looking at the sort of the bigger picture here, I can see that I've got a quadrilateral around here, just inside the orange zone that I've written, that I know 1, 2, 3 of the angles, so I can go and work out this angle in here very easily. Now, for it to be an equilateral triangle, it has to be 60 because all the angles in an equilateral triangle are 60 degrees. So, with that in mind, let's start adding up the angles we are given. So, 122, 93, and 85. Notice that I've written everything in column form, made sure that I've kept everything in line. 2 add 3 is 5, add 5 is 10. 9 and 1 makes 10, 8 and 2 makes 10, so that's 20 altogether. Carry the 2, 1 add 2 is 3. So they add up to 300 so far, and then 360, so that's angles in a quadrilateral. Take away the 300, tells me that there is 60 degrees here, okay? So I'm going to then make that statement that Q to A to P, so Q to A to P, is equal to 60 degrees because of angles in a quadrilateral. Missing angle in quadrilateral. Okay, now from there, because A to Q and A to P are the same, I know that this angle here and this angle here must be the same. Because it's a triangle, I'm going to do 180, take away the 60 that I already know. That leaves me with 120, and because they're the same, I can do 120 degrees divided by 2 to find out that each angle is 60 degrees. So I'm just going to point at this here and say half because isosceles slash AP is equal to AQ. That's what they told us. So that tells you that all the angles are 60 degrees, so therefore it must be an equilateral triangle. Say all angles equal 60 degrees, so it is equilateral. Okay. Question 8. Question 8 says, look at the following descriptions for each of. Hang on. It says, look at the following descriptions of special quadrilateral shapes. Circle the correct name for each one. The diagonals intersect at 90, only one line, or only one diagonal is a line of symmetry, etc., etc. What we need to do is we need to sketch what all of these shapes look like so we can start to work through these. So a kite looks something like this. A rhombus is a pushed over square, so all the sides are the same, so that side there would be the same as the other side, so I can put dashes on it like that. A square, well, I hope you know that one, so I just use it for that definition. So again, all the sides of a square are the same. A trapezium can look like two, okay? You can either just get this sort of one that looks a bit like a shoe, two-dimensional shoe, and you have one pair of parallel sides, so you'd see like points on there rather than dashes, or you can have what is called an isosceles trapezium, where that side there and that side there are the same, and they have one pair of parallels still on the top and bottom there, okay? And then rectangle, we obviously know what a rectangle looks like. Okay, so having those drawn are going to help us try and work these things out. It says its diagonals intersect at 90. So the diagonals of the kite go from one corner to the opposite corner there and there. And you can see quite clearly that I've made 90 degrees. And it says only one diagonal is a line of symmetry. So that line there would fold over on itself. That is the definition of being a kite, is that you do have only one line of symmetry. So that works. Only one pair of sides are parallel. That would be the trapezium from the definition I gave earlier. All four sides are equal. Its diagonals are not equal in length. Now, all four sides are equal, so it's either rhombus or square. They both tick for the first one. Its diagonals are not equal in length. If I look at the square, if I go from there to there, you should be able to see that they are the same length, whereas the rhombus is much shorter to go from here than it is from here. It's nearly twice as long, okay? So it would be rhombus that would be selecting there. Okay, question 9. I'll start to go through it in a moment. Feel free to get started. Okay then, so the first thing we've got to do is work out the missing number here, and then we have to go and plot the graph. Okay, we should know, as this is an x squared graph, it'll look something like that, or it might be upside down or a bit shifted to a side. So it should look something like that. Now, first things first, I would recommend just writing out this formula, but with an open bracket in place of x, and then what goes inside that open bracket is minus 1. Now, using BIDMAS tells me to do the bracket first, which is going to be squared. Minus 1 squared means minus 1 times minus 1. Minus times a minus is a plus, 1 times 1 is 1. So the answer to that is 1. I then have to times that by 2, so that's 2. And I then want to take away 5. 2 take away 5 is minus 3. So that's that number there. The next thing I want to do is start to give myself a y-axis. Now, if you didn't do the following scale, you would have actually lost a mark, okay? You can't just try and make this as easy as possible for yourself. If I go up to 13, I want to try and use as much of the graph paper as possible. Now, 13 would be a really silly one to go, because then I'd have to do 13 divided by 4 and work out each of those things. We either want to go up in 10, so 10, 20, 30, 40, that's not using enough of the paper. So let's try 5s, 5, 10, 15, that seems fine, okay? So 5 goes here, 10 goes here, and 15 goes here, and likewise coming down, minus 5 would go there, minus 10 would come here, okay? Now, in terms of working out the scale, I go up from 0 to 5 in 10 little squares. So if I do 5 divided by 10, which is 0.5, we find out that one little square is worth 0.5, so one little square. Okay, so let's plot minus 2 and 3. So there's minus 2 on the x-axis. 3 would be 1, 2 little squares would be 1, 4 little squares would be 2, 3 little squares would be 3. Okay, another quicker way to work it out is to say, well, in between 5 and 0 would be 2.5, up 1 to go 0.5, so 2.5 and 0.5 makes 3. 1 and minus 3, so I am going to use that trick this time. There's minus 2.5. To get minus 3, just one little square down from the halfway point. Then 0 and minus 5, so literally on the axes there. And then 1 and minus 3. You can see that it's symmetrical, this graph. 2 and 3 there. And then 3 and 13. So that would be 12.5. Up 1, be 13.5, okay? Now this will be a smooth curve. You do not use your ruler, and you don't stop at the end of the graph. You just keep on predicting where you think it would go. So I come to the bottom point there, and then draw my curve going up like so. And similarly here. Okay, so it should look something like that. Question 13. Multiple choice. So if I were you, I'd start trying to work out which solutions it can't be. Because it does that shape there, it has got to be an x squared graph. That means we can discount that one straight away because it's got no squared in it. A minus x squared would be upside down. It's not upside down, so it's not that. And then you can see here that it goes through the y-axis in the positive, so it cannot be that one there. Can't be that one there because it hasn't got plus anything. So by process of elimination, it must be that one there. Okay then, over the page, it says, rotate triangle A through 90 degrees anti-clockwise about the point minus 2, minus 3. There are 3 really important bits of information here. Anti-clockwise is 1. The next one is 2, minus 2, 3. And the one that I missed, I've already gone past it, says 90 degrees. Okay, 90 degrees. Now, what I want us to have a quick look at is drawing a crosshair. So there and there. Now, there's a reason why I've done that. You should know that this angle is 90 degrees. 2 angles would be 180 degrees. 3 angles of 90 would be 270 degrees, and a full 4 angles would be 360. Drawing this on our graph paper will help us identify how much to turn it. I now need to plot the point minus 2, 3. So minus 2, 3 goes there, okay? Now, through the centre of minus 2, 3, I want you to get your ruler and draw a crosshair so that minus 2, 3 is in the centre of 2, 3, okay? Now, getting a piece of tracing paper, you trace the crosshair and the triangle. If you want to, you can use a ruler to do this bit. Okay, now what you do next is you put your pencil on the centre of that crosshair. Anti-clockwise is the opposite way that the hands move around a clock. And then if you look at my crosshair, when it does one full turn on itself, that is 90 degrees. So that is 90 degrees anti-clockwise. So that's where I draw it. However, just show you quickly that 2 turns would be 180, 3 turns would be 270, and 4 turns would be back to where we started on 360. Okay, but as it was, I need to do 1 of the turns, a quarter of a turn. Now, to get it from the tracing paper onto my paper, I go to the vertices or the corners of that shape, and I press really hard. So you can see I'm pressing really, really hard. Take it away, and I can see it quite clearly on my paper, even if you can't, that I had this corner, this corner, this corner. I then get my ruler and join those vertices up. So there, there, and there. Okay. Now, for the next bit, for the next question, question 15, it says, enlarge triangle B by a scale factor of a half using 0, 0 as a centre enlargement. Scale factor of a half is really important. I'm going to make something half as big is actually going to get smaller, and I'm using 0, 0 or the origin as my centre. So what I do is mark where 0, 0 is, that's here, and I go and find the nearest corner to there, which I'm going to use the top one here. How do I get from 0, 0 to this coordinate here? I go across 8 and down 2. So I need to make that half as big. So I'm going to go across to 4 and down 1. So it's going to go there. I could go and do that for each corner. So if I look at this one, across 8, down 8. So I could go across 4, down 4. There. Or I could say, if you look at this length here, it is 1, 2, 3, 4 squares along. To make that half as big, like the scale factor says, I should only go 1, 2 squares along. So either of those ways will work. Get your vertices. Now you join them up. So there, there, and there. Okay then, over the page, have a quick read of it, and I'll start to go through it in about 10 seconds or so. Okay then, it says PQ and PR are tangents to the circle with centre O. RPQ is 30 degrees. Now what they have told us there, they've actually shown that on the graph, or not on the graph, sorry, on the diagram, okay? The bit they haven't told us is that because PR, so P to R, and Q to P, this thing here, are tangents, then I know they are meeting this line here, which goes from the centre of the circle to the circumference. Now that is using something called circle theorems, okay? You should know, as one of your theorems, that a tangent meets a radius at 90 degrees. So I can state here that this angle here and this angle here is 90 degrees as a circle theorem. So I'm going to say angle O to Q to P, OQP, and angle O to R to P equal 90 degrees because a radius meets a tangent at 90. Okay, it's using that theorem. Okay, now I know that's 90, I can see that is a four-sided shape. A four-sided shape have degrees or internal degrees that add up to 360. So I can go and work out what this angle here is. I can work that out by doing 90, add 90, add 30. 90 add 90 is 180, add the 30 is 210. 360 degrees in a quadrilateral, as we've already done in this paper. Take away the 210, gives me an answer of 150 degrees. So now I know that this angle here is 150 degrees. Now, I haven't actually read the question properly to identify what I'm supposed to be finding. It says find the size of O to Q to R. It wants me to know what this sliver of an angle here is. Okay, so I need to go and work that out. Now, to work this out, you see here I've got the centre of the circle going to circumference in both directions. That is what we call a radius. That means both those sides are the same. So what I'm going to do now is do 180 degrees in a triangle. I'm going to get rid of the 150 we know at the centre to get 30 degrees left. So let's say 30 degrees split between 2 due to isosceles. So then 30 degrees divided by 2 gives me 15 degrees. Okay, so the angle there must be 15, as is this one here, also 15. Okay. Next one requires you to know how to use your compass, and it's quite a tricky one. When it says create a perpendicular line from point P to the line AB, there's point P, here's the line AB. To make a right angle, should be a line that comes through and looks something like that with my ruler. Can you see I'm trying to make a right angle there with it? So it's going to be a line that comes off like that, but I have to use a pair of compasses. A pair of compasses is this thing here. To do this from a point, you need to open it big enough so that your point can go on the point they said, point P, so your sharp bit, and it can hit the line in two places, so there and there, and I draw an arc that does what I just said. Okay? So I've drawn an arc that has hit the line in two places. Where that arc has hit the line, you go and put a blob there and a blob there. Okay? You now keep your compass at exactly the same width, and that should be the same distance back to P, and you draw a semicircle from around that point. Okay? You then move over to the other blob, and you draw exactly the same thing. Semicircle from there. Okay, now where those two semicircles meet, so here and here, you draw a line that goes through, and that makes the 90 degrees going through P. Okay, it's going a tiny bit off, it should be fine there. Okay. Okay, then over the page, we are asked to express the following in standard form. Now, standard form, you always write in the form A, which is a number between 1 and 10. But not as high as 10. It can be 1 though. To the times by 10 to the power of some number. If it's a big number, it's a very, very large number. And if it's a negative number, it's a very small number. Now, in terms of what we need to do here, to write this as a number between 1 and 10, it is going to be 4.2. And that is because that's the only place I can put a decimal to make it a number between 1 and 10. If I did it there, it would be 0.42, which isn't between 1 and 10, and here would be 42. Now, if I am going to put the decimal there, how many times does that decimal need to jump? How many numbers pass? 1, 2, 3, 4. So the answer would be not 4, but minus 4, because this is a small number, okay? So if it's a small number with decimals, with noughts in it, you always put a minus there. The next one, we don't have to worry quite so much about taking that out in standard form. When it's timesing, we can use our rules of indices, and then the numbers here can just deal with themselves. Half, or 7.2 divided by 2, is 3.6. And now using rules of indices, 10 to the power of 6, divided means take away, minus 2. 6 take away, minus 2 would be add 2, which would be 10 to the power of 8. And then here, you can't use that rule when it's adding or subtracting. What you need to do is take it out of standard form. So 4.7 times 10 to the power of 5 would jump past 5 times. So there's 1, 2, 3, 4, 5 jumps. So in between each of these go zeros. 1, 2, 3, 4. It turns out there's 4 zeros. So it's 4, 7, 0, 0, 0, 0. And then the same deal with 6.2. So 6.2, but then this time only 4 jumps. So 1, 2, 3, 4 jumps. That's where the decimal is going to go. So in between, 1, 2, 3. So that's going to be 62,000. And then we're taking them away. So 0 take away 0, 0, 0, 0. And then 0 take away 2 we can't do, so we take 1 from there. 10 take away 2 is 8, 6 take away 6 is 0, 4 take away nothing is 4. But it wanted the answer in standard form, so my answer would be 4.08 to have it as a number between 1 and 10, times 10 to the power of. So I've now jumped the decimal back 1, 2, 3, 4, 5 places. Okay, so it's the power of 5 because it's a big number. Okay, getting towards the end of the paper now. I think we've got about 3 questions left. Have a quick read of this question. Okay, then. It says, a group of pupils took part in the Earth National in Stedford. All of them completed in at least one task of the following competitions: singing, dancing, or reciting. 2 of them only took part in the dancing competition. Now, if you have a look, they put 2 there, not in either of the other circles that have singing or reciting, just in dancing. And the key word that let us do that was only. Okay, 2 only took part in the dancing. Now, if you look at the second sentence, it's very similar to the first. It says 5 only took part in the reciting. So in terms of where that 5 goes, it must go here in the reciting bit only. We're then told that no one, so 0 people, took part in reciting and dancing. So reciting and dancing is there. So the bit of the circle that overlaps, which is just reciting and dancing, is 0. That 0 in the middle tells us that no one took part in all 3. No one took part in dancing and reciting as well. We're told that 3 people, 3 took part in singing and dancing. So singing and dancing, those 2 there. We have 3 people. And then told that 9 people took part in the reciting competition. Now, there's a difference here that we haven't seen yet, okay? 9 took part in the reciting competition. That means all of this circle must add up to 9. Now, there's 4 parts of the circle. We already know 3 parts of them. Just highlight all of that. So all of this circle here adds up to 9. We've got 5 so far, so that means this bit here must be 4. Now that is telling me there's 4 people who did reciting and singing. And then finally we're told that 22 people took part in the singing competition. So that means that all of this circle here must add up to 22. Okay, so far we've got 7. So 22, take away the 7, tells you there must be 15 just in this part here. We're then asked to go and work out what is the probability that someone took part in only the singing competition. So it's those 15 people there out of however many people in total. Use your number bonds wisely here. 3 and 2 make 5. 5 and 5 make 10. 10 and 15 make 25. Add the 4 is 29. So it's 15 out of 29. Okay, then over the page, it says factorize 2x squared minus 7x minus 18. Okay, now to do something like this, you need to be able to know how this works. And in terms of how this works, you're always looking for a pair of numbers that times together to give me the back number here, and they add to give me the middle term here. Okay, so we're looking for a pair of numbers that times together to give me minus 18. Now, if they times together to give me minus 18, one sign must be positive and one sign must be a negative, because we know that 2 positives times together to give me a positive, 2 negatives times together to give me a positive also, and one of each sign will give me a negative either way round. Okay, so pairs of numbers that times together to give minus 18, 18 and 1, that works, or 18 and minus 1, but 18 take away 1 is 17. I want minus 7, so that's not my combination. Okay, chances are I'm not going to get this straight off. I'll do a couple of these and add more if I need to. Give me another pair of numbers that times together to give 18. How about 9 times by 2? 9 take away 2 is 7. That's not right. I'm supposed to get minus 7. However, if I switch these 2 numbers now, so it is 2 and minus 9, that does give me minus 7. So to factorize it, I would get x plus 2 must go in one bracket and x minus 9 in the other bracket. I'm then asked to solve this equal to 0. Now this is saying something times something equals 0. So for that to work, either the x plus 2 must equal 0 or the x minus 9 must equal 0. So to get the x by itself, I'm going to take 2 off each side. So x equals minus 2. And then to get the x by itself here, I'm going to add 9 to each side, so x equals 9. Okay, question 16, the penultimate question. Again, have a quick read. I'll go through it in a moment. Okay then, so simultaneous equations to be solved in an algebraic, not a graphical way, so we can't draw graphs, not that anyone ever does. And we've got two equations. Now, the problem is that none of these coefficients are the same. So the x's are 4 and 6, they need to be the same. And the y's are minus 3 and minus 5, they need to be the same to solve this. To do this, get the smallest coefficients the same. So I'm actually going to get the y's the same. So I'm going to times by the opposite coefficient. So 5 I'm going to times by there, and 3 I'm going to times by here. That creates two new equations, which I'll call equations 3 and 4. I need to times everything by 5 in this equation, so 20x minus 15y equals 10. Everything times by 5. And then for equation 2, timesing everything by 3, I get 18x minus 15y equals 3. Okay? Now that those two are the same, if I take them away, they will cancel out. Okay, I'll show you, I'll describe a little bit more in detail as well. So 20x take away 18x gives me 2x. Minus 15y, take away minus 15y. If I take away a minus, I'm effectively adding it. Minus 15y, add 15y would cancel out. And then 10 take away 3 is 7. To get the x by itself, I'm going to divide both sides by 7. So x equals 7 divided by 2, which is 3.5. Okay, so I found out that x is 3.5. Now I know what x is, I substitute it into the nicest numbers in either equation 1 or 2. I always go back to my original two equations. So substitute x equals 3.5 in. I'm going to do it in 1 because numbers are slightly smaller. It'll make my life slightly easier. 4 times by 3.5 minus 3y is equal to 2. Well, I don't know what 4 times 3.5 is, but what I do know is 4 times 3 is 12, and I do know that 4 times 4 is 16. So 4 times 3.5 must be in the middle of those two answers. So in the middle of 12 and 16 is 14. So I can state that 14 minus 3y is equal to 2. Now, I don't like the 3y having a negative in front of it. So what I'm going to do is I'm going to add 3y to both sides. And what that will do is it will cancel out having a negative 3y here, but it will leave the 14, and I'll get 2 plus 3y. Now it's positive, I'm used to seeing it positive. I'm going to get rid of anything that's not physically attached to it, so that will be the 2. So I get 12 is equal to 3y. And now I'm going to get the y by itself by dividing both sides by 3. That will cancel out those 3's there, leaving just y. And 12 divided by 3 is 4, so y is equal to 4. Okay, then final question. It says a cylinder fits just inside a hollow cube with sides of length m. Now it says here that the radius is m over 2. So let's just put some logic into this. If this side was 10 centimeters, this would be half it. That would be 5. Okay, that's all that's telling me. It's just that they're both in terms of the same letter. We're then told the height of the cylinder is m. The ratio of the volume of the cube to the volume of the cylinder is given by volume of cube to volume of cylinder is equal to k over pi. Where k is a number, find the value of k, you must show you're working. And people look at this and go, oh my god, it's absolutely horrendous, there's no way I can do it. It's not as bad as you think, okay? Have a look at this statement here. This tells you to go and find two things. It tells you to go and find the volume of the cube. It tells you to go and find the volume of the cylinder. The volume of the cube is incredibly easy. Volume of the cube will literally be the length, m, times by the width, m, times by the height, m, okay? So it's going to be m times m times m, which is m cubed. Okay? The volume of the cylinder will be the base area. So this shape here, which is the base area, which is a circle. So it's going to be pi times by the radius. Now this is where you're going to get, this is where it does get tricky. The radius is m over 2 squared, and then you times by how high it is, times that by m. Okay, now this is where you'll probably need or find things a little bit tricky. That's a fraction. This isn't a fraction, this isn't a fraction, but I can turn it into fractions to keep it nice and easy for me. Just going to put it over 1. M over 2 squared means times by m over 2 times by m over 2. And then turn this into fraction by just saying it's m over 1. Now I'm going to do pi times m times m times m. That is going to be pi m cubed. And then it is going to be over 1 times 2, which is 2, times that by 2, which is 4, 4 times 1, which is 4. Okay, I now know the volume of the cube is m cubed. I now know the volume of the cylinder is pi m cubed over 4. I now need to write that as a ratio. So I'm going to put that as the volume of the cube, m cubed, ratio dots, volume of the cylinder. So that's going to be pi m cubed over 4. Now they've told me they want to have pi by itself. So to get pi by itself is rather like doing an equation. I don't like this over 4. I'm going to get rid of the over 4 by timesing both sides by 4. That gives me 4m cubed is equal to, ratio dots m cubed. I now want to get pi m cubed. I now want to get rid of the m cubed. So I'm going to divide both sides by m cubed. Now, they cancel out there, and they also cancel out there, which leaves me just with 4 ratio dots pi. That is in the form they wanted, where they said k, where k is a number, to pi, 4 to pi. So k is equal to 4. Okay, that was the final question. Hopefully you found that useful. If you did, please hit the subscribe button, and you'll get instant access as and when I record and release more videos. Thank you very much for watching.